Hey guys, this is Mr. Fry back at you again with another video. This time I'm going to talk about thermal energy and specifically how to use the specific heat formula to solve for the value Q. Okay, so this is your specific heat formula is Q equals mc delta T. Let's take a look at what specific heat means. As a reminder, specific heat just refers to the amount of heat necessary or required to raise the temperature of a unit of mass for any given substance by a given amount, which basically says that specific heat is the amount of heat energy, the amount of thermal energy, in other words, that an object will either absorb or release in order to change its temperature. Okay, and each material tends to have a unique specific heat. Okay, so here is your formula. Let's dissect this thing. Q stands for the heat needed. It's measured in joules, just like all other energy. So heat is just a form of thermal energy. And here we have M, which is the mass of the substance in question. You got to be careful here because it's in grams, not in kilograms like many other formulas. Okay, here we have C is the specific heat of a substance. You'll notice that the units are joules per gram per degree Celsius. And then we've got delta T. Now that triangle just means the change in. It's called delta. It's a Greek letter, and it's all over the place in science. So delta T just means a change in temperature, which you can calculate by taking the final temperature minus the initial temperature. Okay, now keep in mind the specific heat looks intimidating, but this is a value that gets looked up in a table or it's given to you in the problem. I'll show you what I mean right here. Here are the specific heats for some common materials. You'll notice that aluminum has a specific heat of 0.9, copper with 0.38, and so on and so forth. You'll also notice, hopefully, that water has a very high specific heat. So something that has a high specific heat is going to heat up slower. It's going to absorb more joules of energy in order to raise each gram 1 degree Celsius. Whereas things like metal heat up a lot faster, which makes sense because they have a lower specific heat, meaning they have to absorb less joules of thermal energy in order to increase each gram of the substance by 1 degree Celsius. Okay, these will come in handy in all problems. So let me show you a couple where that happens at. Okay, so on the right we have a steel ball, or sorry, it's an iron ball that is being heated up by a torch. It's 250 grams and its temperature increases from 19 to 32 degrees. How much heat did the iron ball gain? Okay, so here we go. Here's how you would solve this problem. You would first look up the specific heat of iron, which will either be given to you in a table or in the question itself. And then you would start with the formula. Okay, here you'll be able to start making substitutions, which would look something, well, here I have a reminder actually built in for you that the delta T just means the temperature final, meaning at the end of the problem, minus the temperature at the beginning of the problem. Okay, so in order to figure that out, you got to be careful what you're subtracting from what in the problem. It says the temperature increases from 19 to 32. So 32 is the final, 19 is the initial. And then we've also got to put the mass in there, so the 250 from the problem will come in handy, and also the specific heat of iron, that 0.450 will go in for C. So when we make these substitutions, I have this, I have the mass, I have the specific heat, and I have the final minus initial temperatures, and then I can put that into my calculator, being very careful. I went ahead and simplified this here, and then put that through the calculator. You should get, for this problem, 1,462 joules. Keeping in mind that's a positive number there because that's the amount of heat, that's what Q means, that got absorbed. So the fact that it's positive means that the thermal energy transferred from the system outside the iron ball to the iron ball. So in this case, it's a torch. So the thermal energy being released by this chemical reaction in the torch is being transferred to the ball. Okay. Let's take a look at the same kind of problem, but in reverse. This time we have the temperature of the same 250 gram ball of iron is being decreased this time from 32 degrees Celsius to only 2 degrees Celsius. How much heat did the iron ball lose? Well, let's take a look at how to solve this one. Okay, keeping in mind we're still going to need the specific heat of iron. We're going to start with the same formula, and as long as we're loyal to the rules of the formula, we will get a correct answer. Okay, we're keeping in mind that delta T is just final minus initial temperature, and these are my substitutions. I've got the mass, I've got the specific heat, and then my final minus initial temperatures. The ball ends up at 2 degrees, so that's our final. And it started at 32 degrees. That was the initial. Now you notice this is going to give you a negative number when you do 2 minus 32. That's exactly what you want. Okay, and you'll see why here in just a second. Keeping in mind that the thermal energy of this ball now, instead of coming from a torch and into the ball, like in the last problem, now the ball is losing its thermal energy to the ice. So we would expect this to come out as a negative answer, which is exactly what happens. It turns out that in this problem, in other words, the answer to this problem, the ball loses, it loses 3,375 joules. So the reason it's coming out negative is indicating that it has lost that amount of heat. I hope you found the video helpful, guys. If you will, please like or subscribe, and I'll see you next time. Thank you very much.